Hey, so just to finish off our last video, it was just show you the working. So if you did that, there we go, there's our final answer. Times them by 5 times by 10. So 314 times by 5 is the same as, sorry, 3.14 times 5 is the same as 314 times by 5. And then we add in the decimal to give us two numbers after the decimal, because our question had two numbers after the decimal, so our answer has to have two numbers after the decimal as well. Over here, just did 314 times 5, and then at the end, you need to make sure you times it by the 10, because 50 is times by 5 times by 10. So you see how this bit here becomes this number. I still have to then times by 10 to give me the final answer. So that's probably the way they'll make it tricky for you, is to make you think with non-calc. So if you're not sure about your decimals, make sure you practice that. As a wee final aside, just remember, if I do 0.002 times by 0.004, and doing 2 times 4 is 8, and then I'm saying how many numbers after the decimal, it's not just the first number. So see over here, we only had decimals in one, but say it was decimals in both of them. There's 6 numbers after the decimal here. I need to make sure that there's 6 numbers after the decimal, 1, 2, 3, 4, 5, 6 in the answer. So don't just count the decimals in this bit. It has to be, if there's decimals in this, that would count in your answer as well. Okay, so I'll just get rid of that. For this one today, we're going to just look at the rearrange. If we can get onto the context question, that'd be great. So for the rearrange, we're not doing anything different. We still fill everything out. We just then have to use our skills from algebra. So let's see, we've got a diagram, parts of a circle, the radius is 6.4. So it's told us it's a radius, that's quite helpful, that's great, but we've got that information, we'll just cancel that out. The major arc length is 31.5, so we're going to write that 31.5. So the major arc is the bigger arc, that's going all the way to there and all the way to there. Excellent. So again, I can just cancel that out. Calculate the size of the angle. So it wants to know this bit in here. So the size of the angle, the reflex angle. So again, reflex bigger than 180. It's giving you a clue, but it's the angle that's opposite the part you know. So it's not asking for the smaller angle in there, asking for the one opposite. So let's fill out our formula then. We're going to say that I've got an arc. So I know that the arc is equal to pi d, which is the area of a circle, times by the angle, divided by 360. I'm just going to zoom in a bit. All right, it looks a bit rubbish. Okay, then we substitute in, so I know the arc. I'll just write down pi because it's not told me to. This will be sounds like a calculator paper. I'll put down pi, multiplied by the diameter, which is twice the radius. That'd be 12.8. And I'm trying to find the angle, so I'm going to write angle in there, divided by 360. So we've got one equation and we've got one unknown. So that sounds good to me. We'll be able to solve that if we rearrange it. And so some people, they would just write arc in here, but no, they've told us the arc. So make sure you get that full substitution in. Okay. So to undo something, we do the opposite, don't we? So I would draw my method line. And over here, I'm going to write what I'm doing to both sides of the equation. Okay, because if I start seeing, if I want to, my first step is going to be times by 360. Okay, if I write over here 360 times and over here 360 times, that's what I'm doing. It gets quite messy. Okay, they cancel out. That's why it appears over here as a different sign. But it gets very messy, so don't write it in the equation. Try and get used to writing it in the method line. So I'll times it by 360, which means that, yep, over here I've now got 360 times 31.5. I don't know why I've changed pen color. Apologies. Pi times 12.8 times by the angle. Excellent. The next thing I want to do is I want to divide by pi and then divide by 12.8. And I can do that in one step. And I'm dividing because over here, these are times in. So I want to do the opposite function to undo them. So what, I'll just draw it in here. What I'm actually doing then is dividing this side by pi and dividing it by 12.8. Notice I've drawn a times there. I'm still dividing by these terms. They would then times each other. But this divide means I'm dividing by pi and I'm dividing by 12.8. And on this side, it means I'm doing the same. So they would then cancel out. But I don't like drawing it that way. I'm just going to do the method line just to show you what's happening. On the next line, it's going to pop up as 360 times 31.5 equals, I'll just put angle over where it was, just to show you what's kind of missing, and that's pi times 12.8. Fantastic. And you can now do that on your calculator. And your angle, I'm going to flip it around, the angle then is 282 degrees. Fantastic. Be careful on the calculator. When I've typed this in, what I've done is 360 times 31.5, divide by pi, divide by 12.8. So I've actually, because they're both divides, the other way you could do it is to write on your calculator 360 times 31.5, make sure it's in a bracket, divided by pi times 12.8 in a bracket. That's okay. What I did was I did the divide by pi, and then I did divide by 12.8, which is also okay. Yeah, so, just be careful with how you write your calculator. There's different ways to do it. Do a quick sense check your answer as well. 282, so we're close to 300. I could look at that and say, yeah, that looks about right. If you end up with 1 or 2 degrees, problem. If you've got 350 degrees, problem. So try and logically think about it. Does this look about right? Sometimes the diagram, won't be, it's not to scale, but I think the SQA do try and help you, and it's in proportion. So just have a quick sense check your final answer. So that's good. We'll maybe make this the last question we do as a context question. So I really like this question. Calculate the shaded area in here. Now it looks super complicated, and it's partially because not all the data from here is up here. So let's just fill in the data first of all. So the radius is 30. So OAD is a sector. So yep, we've got a sector in here, and this radius is 30. So I'll do 30 and 30, which is just going up to this point, isn't it? Just going up to there. Fantastic. I know the angle, that's excellent. So I've used all that, I can just get rid of this. The triangle overall, so the overall length of this triangle is 38. That's going all the way from there to there. And then 55, which is going from O to C. Old references. There we go. Fantastic. So that's me got everything in now. Now, really the hardest bit in this is the start. So get your strategy down in English. What is it we need to get this section, this shaded section? What am I possibly going to have to do? Well, to me, it looks like this whole shape. Take away this shape. Now, if you didn't spot that, just do some sums. Okay. If you see a triangle that's not a right angle triangle and it's all about areas, you should be thinking, right, I'm going to work out the area of that triangle. Same with the sector. I see the word sector, work out the area of the sector. Okay, do something. But in this case, we're looking at the shaded area is equal to the area of the big triangle, take away the area of the small, or the area of the I'll say it's what I'll call it sector. Usually it's in triangles and triangles, area of the sector. Yeah, there we go. So what's the area of the big triangle? Well, that is your half AB sine C, which is a different topic. So if you've not done that yet, don't stress about it. And the area of the sector is going to be pi r squared times theta over 360, theta angle. And then we're just substituting in. So your AB in this case is 38 and 55. And your angle is the angle between those two. That's a good sub. Pi r squared, my radius is 30. It's going to be 30 squared. The angle is 75 over 360. And I would get you to do both of those sums independently on your calculator and then get your final answer. I am a bit pushed for time, so I'm just going to say the final answer then comes out about 420 centimeters squared. So, like I said before, with the context, it's about identifying what the question is asking you to do. So when you see a sector, think about working out the area of a sector. When you see a non-right angled triangle, you're using your half AB sine C. So that's a different topic. We'll cover that later on, actually. Pardon me. But this, having your strategy in English and then slowly populating it, filling it in, taking your time, that's the key to keeping the marker happy, showing them what you know. It's the key to not making small errors because it's very easy to get mixed up. Yeah, but I've labelled my diagram. I've in here used different colours, but clearly labelled my diagram so it's easy for me to put the numbers into my equation. I can see the follow through steps so I don't miss out a squared. I think, oh, yeah, that's 30 squared. It's all the same. So just taking your time, being neat is a big part, and identifying what the question's asking you to do. So I hope that helps, and yeah, on to the next topic.